Hi everyone. So in this lecture, we are going to solve few questions, namely 45 questions on topics like first, follow, LL1, ambiguity, and these things, right? Although this ambiguity is part of TOC, so we will not go much deeper into the ambiguity, but still we will solve few questions here also, right? Okay. So let's just start with the question number 1. So this question I have taken from Berkeley University. What they are saying, consider the following grammar over the alphabet ABD. So this is the grammar that is given to you, right? Now they are saying that find out the first and follow. Now in this grammar, which is given to you, do you remember how to find out first and follow? So what is the first thing that you need to do? You need to check what are the symbols which are nullable, right? Do you remember the nullable? Nullable symbols. So what are the symbols which are nullable here? Can anyone tell me? What are the terminals which are nullable? See, this ABD, right? This is ABD. So I think there is nothing, right? There is nothing. So neither S nor A nor B nor D, right? Nothing is nullable. Okay, not an issue. So basically, if something is nullable, then the first will contain epsilon. If that is not nullable, then first will not contain epsilon, right? So there is no epsilon in the first. That's great. Now, what is the first of S? It will be whatever is the first of A, right? So the first of A is small a, first of and the first of B, right? So what is the first of D? Small d. Small d is the first of D. And what is the first of B? First of B will be, can anyone tell me? What is the first of B? It is small b and small d, right? Small b and small d. What is first of capital A? It is small a, and whatever is the first of small d. First of capital B. And what is the first of capital S? This is ABD, same, right? Now, what about the follow? Since there is no nullable, so you don't need to think too much in this question. You can very easily do. So what is the follow of S? Anyway, it is dollar. It will be containing dollar. And what else? Whatever is the first of B, right? So what is the first of B? BD. So BD dollar. Is this fine to everyone? BD dollar. And what about the follow of capital A? It is the first of B. It is the first of B, which is BD, right? And what is the follow of capital B? So here, let me write it. This is BD. What is first of capital B? Sorry, follow of capital B. It is first of capital S. So what is the first of capital S? ABD, right? See, the follow of capital B will be first of capital S. Is this fine to everyone? Let me know. So it will be ABD. And what is the follow of capital D? Okay, so from here also you need to write the follow of capital B. So follow of capital B will be first of capital S, which is ABD, and first of capital D, which is anyway D, right? So you don't need to worry much. Now, what is follow of capital D? See, capital D is coming here, capital D is coming here. At two places it is coming. So because it is coming here, then it is same as the follow of S. So the follow of S is BD dollar, right? And because it is coming here, then it is same as the follow of B also. So it is ABD. So that's why it is ABD dollar. Is this fine? So the final answers are BD dollar, BD, ABD, and ABD dollar. And let's just see if you can solve this. Again, this question has been taken from Berkeley University. So can you solve this question? Given this grammar, what they are saying, that fill in the following set. First of S will be what? So this grammar is given to you. What will the first of S? Whatever is the first of A. So first of all, tell me what are the nullable symbols? Nothing is nullable, right? Because there is no epsilon here. So that's why it will be very easy. See, the first of capital A will be small a only. First of capital S will be small a only, whatever is the first of capital A. And first of capital D will be small d, right? Only small d. And whatever is the first of capital D. I mean, this is the same as first of capital D, which is small d. Now, can you tell me the follow of capital S? Since capital S is not coming anywhere on the right hand side, so can you tell me what is the follow? Follow will be dollar only, right? Only dollar. And now, what about the follow of capital A? Capital A is coming here, capital A is coming here. So this is B and C, right? B and C. What about the follow of capital D? Capital D is coming here, capital D is coming here. So that is why it is small d and whatever is the follow of capital S. So small d and dollar, right? Okay. So yeah, these are the answers, right? Now let's just see if you can answer this question. So this is saying consider this grammar. And now where ABC the set of non-terminals and XYZ the set of terminals. Epsilon denotes the empty string. So what is the first of capital A? Small x. Small x. So either B is answer or D is answer, right? So can you tell me which one is answer? Small x, and then whatever is the first of capital C. So see, what are the nullables? Can you first tell me the nullable symbols? Is C nullable? Is B nullable? Yes. Is A nullable? No, right? At least Z will be there. So A is not nullable. Is C nullable? No. So only B is nullable. Okay. Only B is nullable. Now let's just solve this. What is first of capital A? It is small x and whatever is the first of capital C. So it is y only, right? It is y. So small x and y. So basically B is the answer here. Can you tell me first of capital B? First of capital B will be small x and epsilon, right? So yeah, so this is capital B. So here small x and what else? And epsilon should be there, right? So small x and epsilon. So I think they have also missed it. Okay, so this is epsilon is also there. So A is the answer here. And what is the first of capital C? What is the first of capital C? It will be small y only, right? Small y. So I think B is the answer here. Okay. Okay. Now let's see this question. Can you tell me the follow also? So in the same question, can you tell me follow? So the nullable symbol is only B, right? Only B is nullable. A is not nullable and C is not nullable, right? These are the nullable symbols. First find out the nullable so that the calculation become very, very easy. Now, what is the follow of A? Where A is coming? Here A is coming. And where else A is coming? Nowhere else, right? So they're not writing dollar, that's fine. But let's just see that because of that, what is the follow of A? It will be the follow of B. Okay. So what is the follow of B? It will be small y and small z. So what is the answer here? D, right? D. Okay. So there will be dollar also if A is a start symbol, but they are not writing dollar. So that's fine. Okay. I mean, they have not given whether A is a start symbol or not. So let's not worry about it. Okay. Yeah. Now, what is the follow of B? What is the follow of B? It will be same, right? This small y and small z. So I think D is the correct answer. What is the follow of C? Follow of C will be, see here, C is coming at only one place. So it will be small z, right? So I think C is the answer here. Okay. Yeah. Okay. So let's solve this gate PYQ. Let's see what they are saying. Consider the following grammar. What is the follow of capital Q? What is the follow of Q? So Q is coming at this place. So first tell me what are the nullable symbols? Always tell me nullable symbols before you find out the first and follow. What are the nullable symbols? I think R is nullable, R is nullable, and S is not nullable, Q is not nullable, P is not nullable. Only R is nullable, right? Is this okay to everyone? Nullable symbol means that whatever is the non-terminal which is producing epsilon in one or more step. So R is only nullable. Why? Because see, this null is only coming at R. This null is this Q cannot drive this null because at least it has to drive Y or I mean, it will take either this or this. So that's why only R is nullable. Nothing else is nullable. Now, if they ask you the follow of Q, then it will be same as first of RS, right? First of RS. So what is the first of R? It is W. And since R is nullable, so that's why you will go to the first of S also. So first of S is Y. So what is the answer here? W and Y. So C, right? C is the answer. Easy question, but you first find out the nullable and then you can solve for this question. So C is the answer. So in all the questions of first and follow, it is better to first find out the nullable symbols. Okay. Then these kind of questions become very easy. Let's just solve more questions. So this question has been asked in GATE 2019. Let's just see what they are saying. Consider the following grammar, and then they are saying let ABD and dollar are the index as follows. Okay, so dollar is 0, D is 1. Okay, so dollar is 0, D is 1, like that they are saying. Okay, compute the follow set of the non-terminal B and write the index value symbols in the follow set in the descending order. For example, if follow set is ABD dollar, then the answer is 3210. Okay, so what is the follow of? They're asking the follow of B. Okay, they're asking the follow of B. Can you tell me what is the follow of B? What are the nullable symbols? Can you tell me the nullable symbols first? B is nullable, D is nullable, A is also nullable. Is S nullable? No, right? So nullable symbols, right? Nullable. Now they're asking the follow of B. So follow of B will be same as first of D. So what is first of D? So here let me write follow of B they are asking, which is first of D, which is small d. And since D is nullable, that is why also follow of capital A, right? Also follow of capital A. So what is the follow of capital A? It is a small a, and that's all, right? So A and D. Now they're saying, if your answer is whatever is your answer, you first index it. So D is 1 and A is 3. So what is the answer if you arrange them in the decreasing order? Then 3 and 1, right? 3 and 1. So 31 is the answer for this particular question. Okay, 31. 31 is the correct answer. Understood? Easy question only, which has been asked very recently. Okay. Now, let's just see more questions. So consider the following grammar. This question I have taken from Princeton University. Let's just see what they are saying. Compute nullable first and follow for all non-terminals. So is this nullable? Is S nullable? First tell me. See, E and F are nullable. Is S nullable? No, right? S is not nullable. So this is not nullable. Now tell me what are the first and follow of these entries. So what is the first of capital S? It is small a, small b, right? Small a and small b. Okay. What is the first of capital E? It is epsilon. It is also epsilon. What are the follows? So let's just see the follow of capital S, right? So capital S is not coming on anywhere on the right hand side. So what is the follow of this? It is only dollar, right? Only dollar. What about the follow of capital E? It will be small a because capital E is coming here. Capital E is coming here, right? So it will be small a and small b. What about the follow of capital F? It is coming here and here. So small a and small b again. Is this fine to everyone? So this question is easy, which I have taken from Princeton University. Okay. So $AB, this is AB, and yeah, these are the epsilons, and this is not nullable. These are the nullable. Okay. Cool. Now let's just see this question. This question I have taken from this university. So what they are saying, the same kind of question, compute nullable first and follow of these non-terminals. So first tell me, is S nullable? Is B nullable? Just tell me what are the nullable symbols here. Is S nullable? See, E is nullable. I think F is nullable, right? Okay. S is not nullable. B will be at least producing this. Capital D could be right because E and F. So these are nullable. These are not nullable. Okay, that's great. Now let's just find out the first. Okay. So tell me what are the first symbol of capital S. I think this is just a small u. What about B? It will be W. And that's all, right? Because this is a left recursion. So it is basically saying that what is the first of B, which is just the recursive definition, and then W only. And what about this capital D? What is the first of capital D? It will be whatever is the first of capital E. And then if E is nullable, then we will see something else, right? So this is Y. And then since E is nullable, so first of capital F also, which is X. And then since this itself is also nullable, so epsilon, because these are nullable. And then X and Y also, right? Y and X. Now, can you tell me the follow? Can you tell me the follow sets? So what is the follow of capital S? It is just dollar. It is just dollar. What is the follow of capital B? It is small b and first of this, right? So small b and first of capital D, which is X, Y. And since this is epsilon, that's why the follow of capital B will be Z also, right? Let me know if you have understood this. Now tell me quickly, what is the follow of capital D? Follow of capital D will be a small z, and I think that's all, right? What is the follow of capital E? E is coming at this place only. So that's why this is the first of capital F, which will be X. And then see this E is coming at this place. So it will be first of capital F. And then if this is epsilon, then the follow of capital D also, right? Follow of capital D also. So follow of capital D will be Z. Okay. So Yash is saying first of D will also have Z. Okay. First of D is EF, which is epsilon XY. Why it will be having Z? D is not related to Z, right? D is not generating Z at all. So it is just E and F, which is X and Y and epsilon. Now tell me, what is the follow of F? Follow of F, right? F is coming at this place, which is same as follow of D. So what is the follow of D? Z. So that's why Z will be here. Understood? Let's just quickly match with the answers. Okay, I don't have the answer for this particular question, but I hope you understood, right? Okay. Now, let's just see this question. This is question number 9. Now they are saying for each of this grammar, find out the first and follow. Can you do this question as an homework? Let me know. Okay. So answer is on the next page. You just try this question as an homework. Okay. Answer is on the next page. Cool. Now again, they are saying the fill in this table, and for first and follow, remember to put epsilon in the first whenever X can reduce to the empty string. Can you also do this this as an homework? Or should we do it now? Okay. Just do it as an homework, right? Answer is on the next page. So that's why I'm giving you as an homework, so that you also get the good practice. Okay. Now let's just see this. What they're saying, consider the grammar given below. Which of the following is or are true about first and follow sets? The non-terminals are X, Y, Z, and the terminals are A, B, C, D, E, F. So this grammar is given to us. Now tell me, is the first of Z same as first follow of Y? First of Z will be what? First of Z will be C and E, right? This is first of Z. First of Z. Now, is this same as follow of by? What is the follow of by? Follow of by will be first of Z, yes, and then this is the follow of by. So I think both are same. You don't need to even compute, because it is coming to be same, because the first of by or the follow of by will be the first of Z, and Y is coming only at one place. Here it is also coming, but it is the recursive definition, right? So that's why it won't matter. So that's why A is the correct answer. But let's suppose this is MSQ. This is MSQ question. Okay, they're saying is or are true. Now tell me, is the first of X and first of Y are related like this? First of Y will be small b, small d, BD. What about the first of X? First of X will be BD and F also, right? BD and F also. So actually it's a reverse way. I mean, it is actually the superset. So that's why it is false. What about the follow of Z? Follow of Z will be what? It is small a only, right? So yeah, that is true. Is the first of Y and follow of Z intersection is phi? First of Y is this B and D. Follow of Z is only A. Is this intersection phi? Tell me. Yes. So that's why D is true. So A, C, D are true. Okay. A, C, D are true. So these are the first and follows of X, Y, Z. So using with this, we can say that answer is ACD. Okay. Answer is ACD. Now let's just move to the next question. Let's just see what they are saying. Consider the following grammar given. Construct LL1 parsing table. Now, can you construct the LL1 parsing table? This parsing table using the grammar. So see, this is capital A gives a small a, and then where will you put this production, right? Where you will put this production? Tell me. See, S is a start symbol here. Let's just do step by step. Let's just do step by step. So for this particular production, where do we put any production? We put the first in the first of this thing, right? So what is the first of this thing? Let's suppose this is production number 1, this is production number 2, this is production number 3, this is production number 4. Now this will be put in the first of capital A. So first of capital A, capital S and B is small a only. So here you will put the production number 1, right? Is this okay to everyone? And what about this S gives epsilon? What about this? Can anyone tell me? If something is producing epsilon, then it will be put in follow of S, right? So what is the follow of S? So follow of S is a small b, because it is same as first of capital B. So it is a small b. So 2 will be put in here. 2 will be put in here. And then what about this? 3 will be put in row of A, and then this column, right? A small a, because the first of this is a small a, and then this 4 will be put in this column, right? So let's just see the answer. Yeah. So here this 2, which is S gives epsilon, this will be put in. So this will be put in follow of S, right? Follow of S. So what are the follow of S? It is anyway dollar and the first of B, which is B. So that's why these are the 2 follows. So that's why it will be put in 2 places. Understood? So it will be like this. So this is the answer. Hope you understood. So what was the grammar? The grammar was this, right? This is the grammar. Now tell me, do you also know how to use this? How to use this parsing table? Do you also know? Okay. Okay. Let's just see if you can tell me. So suppose that I have any string. Let's suppose that I have any string here, which is going something like this. Let's suppose this is AABB. Okay. This is the string that I want to parse using this particular parsing table. Then how to use this parsing table? See, this is a top-down parser, right? Now that's why we have capital S in our hand. So initially we will start with capital S. Now which one to go? So how to tell using this? Which production to use? Either use this or use this. How to tell? See, we will look at the input symbol. The first input symbol is small a. So you have this in the hand, and using this, you want to produce this, right? This is the lookahead. So this is also called as lookahead or the input symbol. So these are the lookahead. Lookahead means that what is the next symbol that you are looking actually. Okay. So if you want to generate a small a at first, then you use this capital A, capital S, capital B, right? So you use this particular production. And then if you have capital A in the hand, and then you still want to produce a small a, then where you will go? Capital A in the hand, then you still want to produce a small a, then you will use this production, and then A is matching. Now you will move to the next symbol. Now you have a small a in the hand, and a small a you want to produce using capital S. So which one you will go? ASB, right? See, this thing is in your hand, and then you want to produce a small a. So if you want to produce a small a using S, you will go with this production, right? You will go with this production. So that's how this table is helping. This table is just like a Google map. Okay, this table is just like a Google map, which means that it will tell you that if there are multiple ways, let's suppose there are multiple ways to choose, that either you choose this production for S or you choose this production, then this table will tell you that which one to choose. So you will be choosing ASB, right? Now you have again capital A in the hand, and using this capital A, you again want to produce a small a. So this one. Now you will go here. Now tell me which one to use. That's interesting. So this is the capital S. This is capital S, and you want to produce a small b using capital S. How you can produce? Using capital S, you want to produce a small b. So you will go for epsilon, right? You will go for epsilon. And now you have capital V. Using capital V, you want to produce a small v. Using capital V, you want to produce a small v. So you will go for this. And this B is coming here. Now you have now you again have capital V. So you will be doing like this. And then input is over. If input is over, and at the last, if you are getting dollar, then you will say that that this is the parsing successful, right? So parsing is successful. How we are parsing? Have you understood? Let me know. So this is something which is in our hand, and then you want to parse the system, right? Then you will choose that, okay, that if you want to generate a small a, then which production to use, then you will go for that particular cell, and then you will choose that production. That's how this table is helping. This table is just like a Google map. Okay. Now let's see this. Consider the following grammar given. Construct LL1 parsing table. So can you construct the LL1 parsing table? Let's just do it quickly. Now see this. This grammar is given to us. First tell me where it will go. It will go in the first of tx. So by the way, what are the nullable symbols here? Y is nullable. T is not nullable. X is nullable. T is not nullable. Capital E. Since T is not nullable, capital E is also not nullable. Right? Okay. Now tell me the first of tx. What is the first of tx? It will be same as first of t, right? Which is this. Let's suppose this is production number 1. This is 2. Okay. This is 2, 3. This is 4, 5, 6, 7. Okay. So this production number 1 will be going to open parenthesis here and int, right? And int here. Understood? Okay. Now this production number 2 will go to row of x and then this plus, right? This, yeah, this is interesting. X gets epsilon. This will go where? This will go where? This will go in the follow of x, right? So what is the follow of x? This is same as follow of capital E, which is dollar, right? Which is dollar. And where else is coming x? Nowhere else, right? So this will go here. This will go here. Now what about this? What about this? This will go to open parenthesis t, row of t, and then open parenthesis. This will go to row of t and int, row of t and int. This will go to row of y and star. This will go to follow of y. Okay. So, okay, have I missed something? Which particular production we have missed? No, just tell me the production number quickly. Okay. 3. So 3 will go to follow of x, right? So what is the follow of x? X is coming here. Whatever is the follow of capital E, right? So what is the follow of capital E? Capital E is coming. Yeah. So in the closing parenthesis also it is coming. So yeah, that is fine. Yes, that's correct. So that's why it will go here also. What about this? What about production number 7? It will go to follow of capital Y. So what is the follow of capital Y? What is follow of capital Y? It is same as, let's just see where is Y. It is same as follow of capital T. And that's all right. And what is the follow of capital T? Capital T is coming, I think, only, okay, here it is coming, and here also. So it is first of capital X, which is plus. So it is first of capital X, which is plus, and then epsilon. So X is basically epsilon also. That's why it is follow of capital E also, right? So follow of capital E, which is dollar and closing parenthesis. Understood? So at these 3 places, this 7 will go. So at plus, dollar, and closing parenthesis. Okay. So this is the answer. Interesting question, isn't it? See, plus, dollar, and closing parenthesis. This will go. So they have directly written only the right hand side, which is fine, right? I mean, generally we are used to write like this, but they have only written the right hand side, which is fine because by default the left hand side is capital Y only. Okay. Cool. So this is the answer that we are getting. The answer is same. Now let's just go to the next question. Now what they're saying is the following grammar is LL1. Justify your answer using first and follow sets. Okay. Just tell me if this grammar is LL1. See here, what is happening? That this is S is going to XD. So since there is just one production, so I think like we do not need to care about this. So that's okay. That's also okay. That's also okay. Maybe there's a problem in this, right? Why I'm saying so? See, this will go to row of S. This will go to row of S, and the columns will be decided like by this, right? So there won't be any conflict. Is there any chance of conflict because of this? Tell me. Is there any chance of conflict because of this? No, right? So that's why I'm saying this is okay, because this is just one production. Now there might be conflict because of this. Let's just see. This will go to small d. This will go to small d. This will go to, since this is epsilon, this will go to follow of capital X. So what is a follow of capital X? This will also go to small d, right? This will also go to small d. So that is why you will say there is a conflict. Okay. So there is a conflict. See, what is the table? In the table, if you have S, X, or let me just write only for X. If I just write only for X, only one row, then there will be the conflict. So this X is saying, let's suppose this is C, this is D, okay, AD and dollar, AD and dollar. So this X is saying that this particular production number, let's suppose this is 2, this is 3, okay. So here you will write in D, you will write 2 and 3. So that's why there's a confusion. So what is the confusion here? Can you tell me what is the confusion here? The confusion here is that whenever you want to generate D using X, then you will get confused whether you will be choosing this or you should be choosing this, right? So for example, let me just give you the example. See, let's just copy this grammar. So can you tell me some string that is in this particular language of the grammar? So let's just take some string, which is, see, it will end with D and X. X is nothing but, this is anyway epsilon. So, okay. So it is, let's suppose DDA. Sorry, DAD. Okay, DAD. Suppose this is the string. Now you start with S. Okay, you start with S. You will say, okay, anyway, I will go to XD. Is there any confusion in like which production to choose? If you are at X, no, right? There is no confusion if you are at X. S. Now, this X, for this X, you will say that, okay, I want to generate this D. If you want to generate the D, then you will say that, okay, either to choose this or this. So for this, you will look at the parsing table. What does the parsing table says? It says that if you have X, and then if you want to generate D, right? If you have X and if you want to generate D, then you are not able to decide that whether to go for this or whether to go for this. So that's why there's a confusion. So hence, I don't know whether C is a good choice or maybe BA is a good choice. So that's why the parser will get confused. So this confusion is called conflict, right? By the way, as a human, can you tell me which one is a good choice? BA, right? As a human, you can tell me that BA is a good choice, because if you generate as BA, then this B later on can give you D, and then this is DAD, right? So as a human, you know that BA is a good choice for this particular string, but maybe there's a string where the C might be the good choice, right? Let's suppose the string is just D. If the string is just D, then see here BA is a good choice. We have resolved the conflict manually, right? As a human, we know, right? But let's suppose the string is D only. In that case, what will happen? Let's just try to parse this. If the string is D, okay, let's suppose string is D only. Then you will say that, okay, till this point, I don't have any confusion. So till this point, things are fine. Now you tell me, if you want to generate D using this X, which one is a good choice? I mean, as a parser will get confused, isn't it? Let me know. So parser will get confused here. Parser doesn't know that which one is a good choice, that whether 2 is a good choice or 3 is a good choice. So parser doesn't know. But let's just see, as a human, do we know? See, parser will say that if you want to generate D, you will get confused. But we know that, okay, if you go to C, then it's a good idea, because later on you can go to epsilon, and then this D will match with this D, right? Okay. So manually we have resolved the conflict here. Manually, right? Manually resolve it. But it will depend on the string. So manually also it's not fixed, right? I mean, sometimes I'm going for BA, and sometimes I'm going for C. So manually also it is not very much fixed. So that's why, like, I cannot say that, okay, manually if I want to resolve the conflict, then always let me just make this as a parsing table, right? It will also be wrong. So we will say that, okay, LL1 is not able to parse, and also it seems like that that as a human also, so it will depend on the string. If it is DAD, then I will say that BA is a good choice, right? Okay. Suppose magically, if someone tell you that instead of having the access to only one element, you have access to two elements, two lookheads. Okay, which means what I'm trying to say here is that, let's suppose that they say, okay, this is not LL1. Okay, this is just a side discussion, which is not LL1 parsing, because in LL1 we just have access to only one lookahead. We will just see one lookahead, right? We will just see this, and based on that we will decide. Now suppose you have access to two lookheads. Okay, there is an algorithm that has access to two lookheads. So first of all, is there any confusion here? No, right? Now let's suppose the algorithm knows that the next two symbols are D and A. Next two symbols are D and A. So since the algorithm knows the two symbols, and here using this X, I have two choices, whether to go for C or whether to go for B and A. So which one you will choose? See, this A can be generated only using BA, right? So most probably using the algorithm, I can decide also that BA is a good choice. If I have access to two elements, two lookheads, okay, then maybe I can write the algorithm. Although that's not in the gate syllabus and all, but I'm just saying that maybe we can write the algorithm if we have access to two elements. Okay, if we can see two elements. So basically it won't be just one element, it will be just a combination of two elements. Maybe you can have AA, AD, DA, DD, right? With dollar also there will be two elements, so there will be multiple columns, and it will be very, very complex. But what I'm trying to say that maybe there, like, we can write the algorithm if we have access to two elements, right? But yeah, let's just come back to the LL1 only. I have even removed that. Let's just come back to LL1 only. So here LL1 will get confused, because looking at D, you don't know whether to go for 2 or whether to go for 3, right? It depends on the string. Okay. Now tell me, is this grammar LL1 grammar? This will go to A, this will go to A, right? And this will go to which one? This will go to A. This will go to first of capital B, which is small b, and first of capital C, which is small c and small d. So because of this, there is no problem, right? Because of this, there is no problem. So I think this is fine. This will go to B, and this will go to C and D. I think this is also fine. This is also fine. So you will say this grammar is LL1 grammar. This is LL1 grammar, right? Understood? Now let's just see this particular question. Is this the following grammar LL1 grammar? What do you think? Can you tell me quickly? Is this grammar LL1? See, because of this, there won't be any problem. But let's just see this. This is A, and then this will go to A, then this will go to the follow of A, right? Follow of capital A. This will go to follow of capital B. Then you will say that follow of capital A is same as, since A and B are nullable, is same as first of capital B, which is B. And then you will go further, because it is nullable. The first of capital B, which is B, then the first of capital A also, which is small a, right? Which is small a. So since this will also contain a small a, and then it will be, since this is also epsilon, so it will also contain dollar, right? Is this fine? Is the follow of A is fine to everyone? Is very interesting, right? The follow of A will be, anyway, it will be dollar, because it is coming to the last, and it will be the first of B and the first of A also. So first of A and B are basically A and B only. Okay. So is this LL1? No, because this A and this A is coinciding. So that's why this is not LL1. So this is not LL1. This grammar is not LL1, right? Okay. Now let's just move to the next question. Let's just see this. So they are saying that what does this table AX contain? Table means that the parsing table that we have for LL1 parser. So what does AX contain? Which production? I think it will contain this one only, right? Easy question. What will AY contain? Can you tell me? What will AY contain? It will be blank, right? There is nothing in AY. It means it is error. It means it is error. If there is a row which is A and there's a column which is Y, then if it is blank, then we say it is error, which means that if you have A in the hand and you want to generate Y, not possible. So the parser will say error. It's not possible to generate Y if you have A in the hand, right? So what about this A and Z? This will also be the error, right? Okay. Now, yeah, this is the correct answer. Now let's just see for Bx, By, and Bz. Can you tell me quickly? For By, I think for Bx, I think this is right. Okay, since this is epsilon also, so let's just first find out that where will this be we give epsilon will go. It will go in the follow of capital B, right? So the nullable symbol is capital B only. So follow of capital B will be first of capital C. So the follow of capital B is first of capital C, which is small z only, right? Small z. Now you tell me where it will go. This will go in the z only, right? This will go to the z, this will go to x, this will go to y. So I think things are sorted here. V gives v comma x, xa, v comma y, v comma z, this one, right? Okay. Now can you tell me for C also? Just tell me quickly. What does C comma x contain? Error, y, error, z, this one, right? Z, this one. Okay, great. Yeah. Now let's see this question. This is MSQ question. They are saying which of the following is or are LL1 grammar? Is this LL1? Tell me. This is not the left factored grammar. So this is not LL1. No. Is this LL1? That's okay. Because of this, let's just check quickly. So what is the first of A? I think the C and D. I think this is okay, right? So this is LL1. What about this? Can you find out? This is okay. Okay. So follow of capital A. Can you tell me follow of capital A? This will be. So what are the nullable symbols? C is nullable, A is nullable. Okay, A and C are nullable. So A and C are the nullable symbols, and S and B are not nullable, right? Okay. Now you tell me what is the follow of capital A? So follow of capital A will be first of small c. So what is the first of small c? Small b. And since it is nullable, that is why follow of capital B also, right? Follow of capital B also. So what is the follow of capital B? It is small a and dollar, right? Small a and dollar. See, the follow of capital A will be first of capital B. So first of capital B, I think is C also. Okay, C also. So A, B, C, dollar, I think everything will be there, right? So follow of capital A will be first of B. So because of that, I have written C, and then first of C, then B. And since C is basically nullable, so that is why it is follow of capital B also. So follow of capital B is small a and dollar, right? Small a and dollar. Understood? So this is ABC dollar. So this will go to ABC dollar. This will go to ABC dollar. And this will go to B, right? It will definitely go to B. B and A and B. So that's why it is not LL1. That's why this is not LL1, right? This will go to A and it will go to B. That's why this is not LL1. For this, it is fine. Now, this might be okay, but let's just check this. So it will go to follow of capital A. So what is the fall of capital A? It is small c. So let's just see the nullable here. Capital S, capital A, capital B, capital D, capital C. What are the nullable symbols? A is nullable, D is nullable, A is nullable, D is nullable, C is nullable. Is S nullable? Is B nullable? No. Since B is not nullable, so S is also not nullable. Okay. Now let's just solve this. What is the follow of capital A? What is the follow of capital A? Follow of capital A here, right? In this grammar. It will be same as first of capital B, which is basically small c, and then that's all, right? Okay, small c only. So this will go to small c. Now, can you tell me first of capital C? First of capital C? Small b and dollar, right? So first of, so this will go to first of capital C and A. So first of capital C is B and it will go to A and B. So do you think there's a problem because of this? See, this will go to C, this will go to C, this will go to this capital C and A. What is the first of capital C and A? B and A, right? A and B. So that's why it's not a problem. It's okay. This is anyway okay. This will go to fall of capital D, which is same as the fall of capital D is same as fall of capital B. So what is the fall of capital B? I think it is just dollar, right? B is coming only at one place, but is same as fall of capital S, which is dollar. So it will go to dollar. It will go, sorry, this will go to dollar. This will go to small a. So I think that's also fine, right? And what about this? This will go to B and fall of capital C. What is the fall of capital C? I think only small a. So I think this is also fine. So this is LL1. So which means that 1 and 3 are not LL1 and 1 and 3 are not LL1, 2 and 4 are LL1, right? This is no, right? This is yes, this is yes. Okay. Cool. Now let's just solve next question. Can you solve this question as an homework? Which of the following is your LL1 grammar? This is MSQ question. Just try to solve this as an homework. Okay. I've taken this question from Washington University. Okay. The answer is on the next page. So just try as an homework. Which of the following is your LL1? Can you again solve this question as an homework? Answer will be on the next page. Okay. Again, this is MSQ. Okay. Don't skip these questions. Just for the sake of practice, just solve them. Okay. Just solve them. Now let's just see this question. What they are saying. Consider the following grammar over the alphabet CDE. Okay. This is CDE. Now they are saying that fill this table for first and follow. Okay. Can you tell me quickly what are the nullable symbol here? Okay. Let me just write this grammar a little more clearly. Okay. So what are the nullable symbols here? Nullable symbols are A and only A, right? So you will say SAB nullable. For the nullable, this is the only nullable. Okay, nullable. So it is better to find out the nullable so that you do these questions quickly. Now, what is the first of capital S? This will be same as first of capital A, which is D. Okay, maybe we can find out first of capital B first, which is small e. Then first of capital A, which is epsilon and D. And then first of capital B, which is small e. Now tell me first of capital S. It will be first of capital A, whatever it is, E and D. And if it is epsilon, then it will go to first of capital B also. Okay, so that's fine. So I think E and D only. Now can you tell me the follow of capital S? It is dollar only. What about the follow of capital A? It will be same as follow of capital S, anyway dollar, first of capital B, E, and then yeah, that's all right. And then follow of capital B also. Okay. So let's just find out the follow of capital B. Can you tell me the follow of capital B? It is a small c and first of capital A. First of capital A is D and E. And if it is epsilon, then that's why the follow of capital S, which is dollar. So these are the follow of capital B. Now, if you find out the follow of capital A, so follow of capital A will be follow of capital B also. So since it is follow of capital B also, so C, D, I mean, you need to write everything here also. So C, D, E, and dollar. Is this fine? Okay. So it is C, D, E, and dollar. Let's just check it. C, D, E, in dollar. Okay, cool. Now they're saying fill in the column of heading a row corresponding to a predictive parser element. So can you fill this? Where will this go? This will go to first of BC. What is the first of BC? This will go to E. This will go to D. This is a small c. Nothing will go here. This okay. Let's just check whether anything will go here or not. This is A gives dollar, right? So it will go to follow of A. So follow of A means it will go to everything everywhere. So this epsilon will go everywhere, right? I'm just writing right hand side. Okay. So since there are multiple conflicts, that's why it is not LL1. Okay. So is this grammar LL1? This is the part C. So what is the answer? This is not LL1. Okay. No. See here the multiple conflicts, right? Not LL1. Okay. Let's just see this question. Is the given grammar LL1? See here, you need to check only for this. So this and this. So what is the first of this? Since this is nullable, it will go to A, it will go to B. Is this LL1? Tell me. Yes, right? Yes, because it will go to A, it will go to B. So that's why yes. Okay. Now tell me this. Is this grammar LL1? It is okay. This is nullable, this is nullable. So this will go to small a, this will go to small b. So I think this is also yes. Okay, this is also nullable. Okay. Now let's just move to the next thing. Okay, there is some power issue here, but that's fine. So the grammar is LL1. Okay. So this is LL1, right? Now let's just go to this. This question has been asked in 1998. What they are saying? Build an LL1 parsing table for the language defined by LL1 grammar with the production. So you need to write the parsing table. So this is some non-terminal program, okay, which is basically giving you these things. Can you write the parsing table? So this program and begin will be having this. This will go to D, this will go to S, this will go to semi, this will go to follow of Y. Follow of Y will be same as follow of X, which is end, right? And this will go to end. So that was the only tricky. This will go to end. Easy question, right? Okay. Cool. So you can do this. Now let's just see this. This question has been asked in GATE 2001. Okay, let's just see this. This question has been asked in GATE 2001. So what they're saying, consider the following grammar with the terminal alphabet this and start symbol E. The production rules for the grammar are this one. Compute the first and follow sets. Complete the LL1 parsing table for this grammar. Can you do this question as an homework? Tell me. I think you can do this question as an homework also, right? Okay. Okay. Great. Now let's just move to the next question. So you can do this question as an homework. Okay. Now let's just see the next question. This question has been asking GATE 2006. Now what they're saying in the predictive parsing, M of the parsing, like parsing table, they are saying the parsing table name is M of the grammar. The entries M, S, ID and S, R, dollar will be what? So S, ID. Can you tell me that S, ID will be having something or it will be null? See, by the options only, you will say that D option is obviously wrong, right? Can the S, ID contain this? Can S, ID contain this? Obviously no, right? So D option is anyway wrong. So it can never contain this. Now it can either contain this or maybe it is empty. But all the options are saying it is containing this. I mean, that's not very difficult to find out whether it is containing or not. Anyway, this F is giving ID, so it will be FR only. Now tell me what will be R dollar? So R dollar either it will be empty or it will be containing this, right? So what is the fall of R? It will be same as fall of S. So that's why it will be containing R dollar will definitely be containing this. So what is the answer? A, right? A is the answer. Okay. Easy question, but yeah. I mean, quite an easy question. You can easily do this question, right? Okay. So let's just see this. Now they're saying in this LL1, the table is also represented like this entries. So they're asking first and follow itself. Can you do this also as an homework? Okay. So because I want you to get practice, so that's why I'm suggesting you that you do these questions as an homework, right? All of these questions as an homework. Now they are saying that what will be these entries, E1, E2, and E3? Can you also do this as an homework, or should we do this now? Okay, just do this as an homework because it will be a good practice to you, right? Definitely do it. Okay, don't skip these questions. Answer is on the next page, but you should do it. Okay, let's just see this question, what they're saying. So let's just read this question. LL1 is a type of parser that start with start symbol and reach to the input string. Yeah, that's true, right? It's a top-down parser. Now, when it uses a specific production like X gives Y, that's called derivation. Okay, so which means that in the parsing, see in the parsing, let's suppose S gives AS, then they are saying that whatever is the production you are using that's called derivation. For a given LL1 grammar, how many derivations are required to parse this string AEBB? So they are saying that how many derivations you will be needing to parse this string. Now, whenever you are using any production, that is called derivation. So how many derivations total you will be needing to parse this string AEBB? Okay, can you tell me? So you want to parse AEBB. See, see, what you can do, you can, let me write the method one. Okay, the method one, which is a long method. What you can do here in this method, you can say that, okay, the first thing that make parsing table, which is obviously a little lengthy, and follow the table and start from start symbol and reach to the and parse basically and reach to the input string and parse. So let's just try doing this, right? Let's just try doing this. So if you do something like this, let's just see. See what you can do. You can start with S. You can start with S. Now you will say that, okay, here if you have two options, let's suppose AS and AB, which one you will go? I think you should go to AS only, right? You should go to AS only. Okay. Now from this S, without making parsing table, I'm telling you by the just intuition, from this S, again, you want to go to E. So which one you will go? If you want to go to E, will you go to AS? No, right? AB. You will go to AB. Now from this A, you want to get E. If you want to get E, should you be going to XYZ, or you should be saying that, okay, epsilon? See, if you say epsilon, there is nothing, right? So you should be going to XYZ, I think, right? So from here, you should be going to XYZ. I'm doing without using the table, just using the intuition. Okay, X, Y, Z. Now, from this X, you want small e. Should you be going to this or epsilon? I think epsilon, right? Okay, so let me just push it a little further. So the input is AEBB, and I think A we have already produced. We are looking for E. Now from this X, where we will go? From this X, we will go to CS or epsilon. We will go to epsilon. From this Y, if you want to produce E, where we will go? You will again go to epsilon. From this Z, if you want to produce E, where you will go? You will go to E and S, right? You will go to E and S. Now this E and E are matching, so that's why that's good. Now from this S, where you will go? From this S, you will go to AS or capital AB. You will go to capital AB because you want to produce B now, right? Now, from this capital A, where you will go? From this capital A, if you want to generate B, then should you be going to epsilon or xyz? If you go to xyz, then I think you will not be able to generate B, right? So you should be going to epsilon. And then this B and this B will match, this B and this B will match, and that's all, right? So how many deductions we have? Sorry, how many derivations we have? This is 1, this is 2, this is 3, 4, 5, 6, this is 6, and then 7, and then 8, right? 8 we have. So we have 1 here, 2 here, 3 here, 4 here, 5, 6, 7, and 8. Okay. So what is the answer? Answer is 8. Okay. Answer is 8. Understood? Okay. So I hope you understood, right? Easy question. But tell me, can you also do this using, I mean, instead of the tree, can you also do the same question using the leftmost derivation? The same question? Or the rightmost derivation? Which one you will prefer? This is AEBB, right? Leftmost derivation, right? So, I mean, you can draw the tree or you can use the leftmost derivation. So first you will go to AS. Okay, let me do the leftmost derivation. Okay, great. So Satyam is saying that he did leftmost derivation. That's really great. Okay, because leftmost derivation and top-down parser is same. Now, for this leftmost derivation, do you think you need the table? Do we need the table? No, we need the table, right? We need the table for either parse tree or leftmost derivation. We anyway need the table, but it's just that you can do in just, I mean, the one line. So you anyway need the table. Why? Because you will get confused here. Should you be going to AS or AB? So that's why you need the table, right? So AS now. So from this A is matching. Now you want to go to E. So from this, you will anyway say that AB, right? So this is. Now the leftmost is capital A. Now from this capital A, you want to match this small e. So that's why you will go to XYZ, right? So this is XYZ, then B. And then let's suppose that they say that from this, you are anyway doing the leftmost derivation. Then what will the next thing? Then you want E, right? So that's why this is YZ. Then you want E, that's why YZB. That's why this is AZB. And then this will be AESB. And then it will be AESB. And then it will be again A E is matching. So now you want B. So since you want B, you will go to AB, right? AE, capital A, B, and B. And from this capital A, you will go to epsilon. So AEBB. So how many derivations you required here? 1, 2, 3, 4, 5, 6, 7, 8. Okay. These are the 8 derivations we need. Okay. So we are doing here, you can say this method 1 could be the long method where you need the parsing table. But in the method 2 or something where you don't need actually the parsing table, which means that by intuition only you can guess that which one to use. Okay. Okay. So here, skip it and use intuition. Okay. This I'm just saying it is, maybe you can say it is method 2. Okay, you don't need to basically make the parsing table. Now let's just see the answer. See the answer, in the answer itself, they have used a leftmost derivation. Is this correct? Definitely, isn't it? So this is definitely correct. So you should know the connection. So if they are saying that parse it using LL1, if they are saying parse it using LL1, then it is same as saying parse it using LL1. It is same as saying use leftmost derivation. Okay. This is leftmost derivation. Understood? Now let's just go to the next question. Okay, let's just see this question. So what they're saying, that consider this grammar G consisting of 3 productions. Okay, let S and A represent 2 non-terminals in this grammar, while small a and small b denote the terminals. two productions of G are provided and one production of the form A gives alpha is missing. So this is production number one, this is production number two. They are saying that one of the production, which is A gives some alpha, okay, of this form is missing. Which statement is true regarding this scenario? There exists an alpha for which G is LL1 grammar. So what do you think? So this is something like this, right? Do you think this can be LL1 for some alpha? Let's suppose alpha is small a. If alpha is small a, then can it be LL1? If it is small a, can it be LL1? Then given grammar is LL1? No, right? If it is small b, then because it is not LL1 because both will go to small a, right? So what about a small b? The same thing. So can it be LL1 for a small b? Tell me. Can it be LL1 for a small b? Obviously no, right? Because this will go to small b, this will go to small b, so that's why no. Okay. So now only A and B are left. Now tell me, there exists an alpha for which this is LL1 or this can never be LL1. So which means alpha means that something is missing here. There exists an alpha for which it can be LL1 or it can never be LL1 for any alpha. There is no alpha for which L can. There is no alpha for which L can be LL1 grammar. What do you think? Yeah. So interesting answer here is yes, there is alpha, which is just epsilon, right? If you put epsilon, then this will go to small a, this will go to small b. So that's why this question is little interesting. So you will say there exists an alpha for which there is LL1 grammar. And what is that alpha? Alpha is epsilon. Okay. So see here, alpha is epsilon, right? Nice, right? I mean, you could do this B as an answer, but just be careful. Okay. So again, they're asking the first follow and this parsing table filling. Can you do this as an homework? Okay, just try these questions as an homework because this will be the good practice to you guys. Okay, which of the following is or are LL1 grammar? Let's just do this quickly. Or maybe if you want, you can try this. So you just try this, right? Let me see if the answers are given. 4 of the answers are given. These 2 answers are not given. So let's suppose this is A, this is B, this is C, this is D, this is E, this is F. So you just try them out and just let me know what are the answers. Okay. Okay. So Gaurav is saying how first one is LL1. See, this is Z. This is basically, this will go to, because it is left recursive. Yeah, that is true. Yeah, it cannot be LL1, right? Okay, actually, maybe there is some alignment issue. So let me just remove these answers. Maybe they do not directly belong to this particular grammar. Okay, so there could be some alignment issue or something. So the answers are not exactly to this A. So you can solve and you can let me know what are the answers. Okay. Yeah, that's correct. It cannot be LL1 because it is a left recursive grammar. Okay. Okay. So can you left factor this grammar? Can you left factor this given grammar? Do you remember how to left factor? For left factoring, what we do, we say, so let me just tell you very interesting way to do left factoring. See, whatever is the common, you just take something like this, okay? You just take this as a common, S1, and then this is 1, okay? So you just write something like this, okay, for now, and then you just say that, okay, let me just say this is S dash. So S gives 0, S dash, and then S dash gives S1 and 1, okay? You just write something like this, and then which means you just say that, okay, let me just take 0 common, and then you say this is S dash, okay, this is S dash, and then for S dash you write like this, okay? So see here, you just write like this first, you say that 0 is common, and then you write like this, and the new grammar will be something like this. Okay. Now let's just see more questions. So what they're saying, give the LL1 parsing table for this grammar. Is this the LL1 grammar? Okay. Just tell me, is this a LL1 grammar? Obviously no, right? Obviously no, because this is not left factored. So this is not the LL1 grammar. If not, then they are saying transform this into the LL1. Can you do the left factoring here? How to do it? See, this is X, A, Y, and then you take this Y common. It will be A epsilon. So what you will say, that let me just say this is A star or A dash. So it will be X, A, Y, A dash, and then A dash will be A and epsilon, right? You can do something like this. Okay. Okay. So this is the left factored grammar. Now let me write the whole grammar. S gives A, and then A gives X A, Y A dash gives capital A and epsilon. Okay. See here, is this LL1? Tell me. So because of this, no problem. This is X, this is Y, no problem. This is A, which means it will go to X and Y. This will go to follow of A dash. Follow of A dash is follow of A, which is dollar. So it will go to dollar. It will go to dollar. It will go to X and Y, right? Tell me, if you do the left factoring, then it is always LL1. Can I say that after left factoring, then the grammar is always LL1? Okay. The answer is no, right? No. Why? Because there could be left recursion, but what is the bigger region? Let's suppose I say after left factoring and left recursion, is the grammar always LL1? After left factoring and after left recursion, is the grammar always LL1? No, right? Why? And left recursion. Yeah, maybe the grammar is ambiguous, right? Maybe the grammar is ambiguous. Maybe grammar is. Can you check if a grammar is ambiguous? Tell me. Can you check if a grammar is ambiguous? Is there any algorithm to check the grammar is ambiguous? No, right? So for the ambiguity, as we know that for the ambiguous grammar, have you seen these things in the TOC? Since it is a TOC topic, so you might have seen this. Okay, not yet. Okay, you have seen, right? So this grammar for the ambiguous grammar, what we say, that there is no algorithm to even detect if grammar is ambiguous. Ambiguous, yes, this is undecidable, right? And what else? Also given ambiguous grammar, there is no algorithm to convert that into non-ambiguous, right? There is no algorithm to convert into non-ambiguous. Have we seen examples where we manually did ambiguous to unambiguous? Have we seen some examples? Yes, right? So we have seen, I think, 3 to 4 examples where we have manually converted, right? Yes, we have in the previous lectures we have seen. So they're like, I mean, those examples are just based on the intuition. There is no algorithm as such to convert. Okay. So those examples are just to make sure that you understand that, okay, even if let's suppose in future for some reason, not for the exam, okay, for the GATE exam, they won't ask you to convert because there is no algorithm. But let's suppose for some reason you want to convert, then can you convert based on the intuition? So that's why we have seen multiple examples. Okay, cool. Now, can you quickly left factor this grammar? How to left factor? You just need to take common. Okay. So can you take int common? Let's just take int common. It will be epsilon. It will be plus e. It will be minus e. That's all right. And then it will be e minus e. Now, from here, you will say this whole thing is nothing but e dash. So you will say e dash is going to epsilon plus e minus e. Right? Very easy method. You just take the common. Okay. I mean, just for the sake of understanding, think like that you have taken the common. So what is the final grammar? The final grammar will be like this. E gives int e dash slash e minus e, and then this. Okay. So that's how you can left factor it easily. See here, this is the answer. Okay. Now they are saying left factor and remove the immediate left recursion. So first you need to left factor this. This is from the Stanford, and then you need to remove the immediate left recursion. Okay, let's just see this quickly. Let's just remove the left factoring. I mean, let's just left factor it. So let's just see that how to left factor. Okay. So by the way, for this left factor, many of the coaching teachers use a term that is called non-determinism or something, right? Non-determinism or something. So basically, there is no standard resource which says left factor and non-determinism is same. Okay, non-left factor, non-determinism, these are same or something. So non-determinism, I don't even know whether it is a standard term or not. But some people, some coaching teachers use instead of saying left factor, they say non-determinism. But this is not a standard term. I mean, in the sense that there is no textbook which says left factor and non-determinism are same. Okay, non-determinism could be something else, but it is not left factor for sure. Okay. Anyway, let's just continue. So let's just left factor it. Now, what you need to do, you first need to take common, right? So let me just remove this. You first need to take common. So what you will be taking common? You will be taking C common, right? So you will say that this is S gives small c, and then you write everything, right? This is capital B, small b, capital B, small d. Yeah, that's all, right? Okay. And then from here, what you need to take common? Capital S. This is a small a, capital A, right? Understood? Now, you can say this is S1. You can say this is S2. So basically, this is S1. This is S2. Now, interestingly, in this S1 also, there is a capital B that is coming. So you need to again do the left factoring. Okay, for this S1 also. So what is the answer after the left factoring? So let's just call it capital X and capital Y. Let's just call it, okay, just to match with the answer, let's just call it capital X and capital Y. Capital X and capital Y. So this capital X will be again having the left factor term. I mean, it is the left factoring is not removed, right? So which means it will be capital A, capital B, small e, capital B, small d. And then S will be small c, capital X, capital S, capital Y. And Y will be small c, capital A. Tell me, have we left factored completely? Have we left factored completely? No, right? Because of this B. So let me again do the left factoring. Let me just see that what they have used. Okay, they have used Z here. So if you want to again do the left factoring, what common you will take here? You will take B common. Yes, you will take B common. So that's why it will be B is common, E and D. So this is, let's suppose this is Z. So what is the final answer? The final answer will be this is S, right? This is S, which is as it is, CX, SY. Then X will be A, and then B, and then this is Z. Sorry. Yeah, that is correct. A, B, and Z. Yeah. This is A or BZ. And then Y will be small c, capital A, and then Z will be small e and D. Okay. So now it is completely left vectored. Okay. Now they are saying that we also need to remove the left recursion here. So do you remember how to remove the left recursion? Do you remember? See, here, do you first of all tell me, do you even have the left recursion? Let's just check. This S is having the left recursion, I think, right? So yes, there is a left recursion. So how to remove it? Let me just quickly recall you. See here. Let's suppose that there is capital A, which is giving you capital A, small a, and B. Which means, can you tell me what it is generating? What is the language it is generating? It is basically, it will start with A, B, and then A star, right? B and then A star. Ultimately, it will generate B star. Which means if you want to remove the left recursion, you will say wherever it is not a left recursion, I mean, you will write B A star, right? I mean, you could have written directly like this, but is this the standard form? Obviously no. So this is not a context free grammar. So that's why instead of A star, let me just call it A prime. And then from this A prime, can I say it is something like this? Can I say something like this? So that's how you remove the left recursion, right? So that's how you remove the left recursion. Now, suppose if I give you, and I ask you, can you immediately remove? Then what you will say? Yes. Let's just quickly do it. How? Wherever there is no left recursion, so it may start with this. So that's why you need to write that. And if this is a left recursion, then you need to basically convert that, right? Okay. So that's how you removed it. Now, can anyone tell me how to remove the left recursion in this? Let me give you the next example. How to remove left recursion in this? Can you tell me? Can you tell me what is the answer you are getting here? So it will be A gives wherever there is no left recursion. This is C. And now this is A, and I mean, this is basically you are saying A gives capital A. So here also left recursion, here also left recursion. Can you tell me how to do this? Okay, CA1 and then CA2, wherever is the left recursion, right? Is this okay to everyone? And then okay, let me ask you, is this fine? Then A1 should be, let's suppose this is this fine? Or there is some problem with this? Let me know. Yeah. So is this the correct transformation? Okay. See here that here in this particular grammar, there was only one way to generate C, right? But here I think that you made the grammar ambiguous. You are saying that I either go like this and or go like this. So you made the grammar ambiguous, right? So tell me, is this a correct way? So can you tell me how to left factor in this case? Can you quickly tell me what are the modifications we need to do here? Just let me know what you're getting after doing the left factoring. Sorry, the left recursion. Okay, see here, this is not the correct way. So how to do it? So first of all, tell me, given this particular grammar, whatever string that you get, it will always start with C, isn't it? So it will always start with C. So that's why let's just do something like this. And then this A prime can go to, so because you need to generate this, you need to generate this also, or maybe mix of this, right? So that's why A prime will go to A prime, B A prime, and then epsilon, right? So that's how you will convert. Now let me just ask you few more. Okay, let me just ask you few more. Tell me, can you convert this? Can you convert this? Let's suppose this is A, which is going to A, B, C, and D. Can you convert this? So what will the answer here? See, here it may start with C or it may start with D. So since it may start with C or D, so that's why if you want to remove the left recursion, then you will say, okay, it may start with C or it may start with D. So, or it may start with D, right? So that's why you will write something like this. And then this A prime, wherever is the left recursion, you will convert that to the right recursion. So this A prime will be like this. Okay. Okay. Just tell me one more. Let's suppose this is capital A, which is going to capital A alpha, capital A small x small y, capital A beta. Let's suppose this is C. Let's suppose this is DE. This is F. Okay, something like this. Now tell me, if you want to convert that to non left recursive, which means if you want to remove the left recursion, then what you will do? You will say it will be something like this. See, here you will say it is basically going to this like this. So it will either start with C or D or F. So you will write something like this, either C or DE or F, right? And then this C, then you will say that here this A prime will go to either this or this. So wherever is the left recursion, you will convert that to right recursion. X, Y, A prime, beta, A prime, and then epsilon. Okay. Now in this question, let's just see what they have said. They have said that, okay, this is the left factored grammar. And now you want to remove the left recursion also. Can you remove the left recursion from this? Okay. Where is the left recursion? I think left recursion is at this point in time, right? So you will convert this, I think only at this. Okay, only at this. That's very, very easy. So you will convert this. You will say that this is basically saying it will start with anyway CX, right? It will start with anyway CX and then S prime probably, right? So this S prime will go to Y, S prime and epsilon. Okay. And all of this is as it is. So let me just check the answer. See here. Okay. All of this is as it is. You don't need to change these things. You only need to change this much. Okay. This one. Okay. So that's how we have removed the left fact. I mean, we have first left factored it and then we have removed the left recursion. Now let's just see this particular question. What they're saying, eliminate the left recursion. Can you eliminate the left recursion quickly? So if you observe here, this is not the direct left recursion. This is indirect. Okay. This is indirect left recursion. Do you remember the indirect left recursion? How to eliminate the indirect left recursion? Yeah. So just take some arbitrary order and fix on that. Okay. Let's just take the order S, R, and P. Okay. Let's suppose this is the order and we are fixing on this. Okay. You can take any order of your wish. Now, first copy S productions. Is there a left recursion here? Tell me. Is there a left recursion here? Since there is no left recursion here, you will copy the next productions. Now, can anyone tell me what is the first step here that we need to do? What is the first step here? We need to replace S productions, right? Which is P and B. So basically you will replace with P and then you will replace with B. So it will become PP. If you replace with P, you will become like this. If you replace with a small b, it will become like this, right? So it is a replacement. Understood? So this is the very first step that you need to do. Now, can you tell me what is the next step? What is the next step? Remove the left recursion if it is there. Is there any left recursion now? Since there is no left recursion, don't worry about it. So this is what you got, right? This is what you got. Now just take the last production, a last non-terminal production, which is P. So P gives RB. Now tell me, this P gives RB. Now tell me what is the next step you need to do? You need to replace this production of S and production of R, right? Production of S and production of R. So here the R is only there. So let's just replace this. So R has these three productions. So maybe let me just copy as it is. Okay. So basically after replacement, what you will be getting is something like this. Okay. Let me just append B only. Okay. So this is P. Tell me, is there any left recursion here? Is there any left recursion here? Yes, right. So basically, finally, we got some left recursion. Now we will remove the direct left recursion that we have. So this is what we got, right? This is what we got, and then this is what we got. But ultimately, there is a left recursion here. So let me also remove the left recursion. Okay. There are two p's, but I think it's fine. Let's just see. So how to remove the left recursion? See, it will start with anyway. It will start with CV. So you will say that this will be this P will be, it will be starting with CV, right? Now, what to do here? Let's just write P prime. Okay. Then this P prime will be going to, there is a left recursion here, there is a left recursion here. So that's why you will say you can convert that to a right recursion, which means this is PAB. Okay. PAB and then P prime. This is BAB, and then P prime and then epsilon, right? So these two are also the answer. Understood? Let's just check if the answer is same. So the final grammar is S gives PB. Yeah, that's correct. R gives PSAC. Okay. PSA and C. Just a second. So this was R. Okay, actually, yeah, we need to replace it. We anyway need to replace it, but I think they have not replaced this. Yeah, actually, I copied it wrongly. It is a replacement only. Okay, replace the productions of S. So in the final answer, I copied wrongly. This is something which I copied, which anyway, so not worry about it because I copied it wrongly. We anyway need to replace. Okay. And then this is correct, right? This is CBP prime and then PAB prime and this thing, right? So the final grammar is this. Okay, that's the correct answer. I forgot to write it. So, but anyway, that's fine. But the final answer is this. Okay, this is the correct answer. Understood? Okay, so let's just read the explanation. So they are saying, first, we will eliminate indirect recursion by choosing an arbitrary order of SRP to deal with the non-terminals. Let SRP is this chosen order. Okay, they have also chosen the same order, SRP. And then what are the steps that you already know? Okay. So actually, this indirect left recursion is not taught everywhere. Like I have not seen any at any other video explanation that they have taught this indirect left recursion. But I hope you understood that how to remove the indirect left recursion also. Okay, let's just do one more question and let's just do the indirect left recursion removal for this particular question also. Consider this grammar. What they're saying, eliminate the left recursion. See, this is not the direct because this B is giving A and A is finally giving B. So that's why it is indirect. Let's just choose some order. Let's just choose ABC. Okay, let's just choose this as an order. Now tell me, what is the first step? You will write this as it is. Okay, this will be as it is. Now, let's just see this B is giving A. That's interesting. Now let's just remove or let's just replace the productions of A. So the A is B, A, and C. So now can you tell me how to replace? How to replace? You will say that, okay, for this A, you will be writing, for this A, you will be writing BA and then A, or maybe you can replace in 2 steps and then C and then A. Okay. And then again you need to replace, or is this fine? Tell me. We again need to replace because there is a capital A again. So that's why you need to replace this. This will be BA, BAC. Okay. And for the CA also, C, BA, C. I hope you are getting this. BA is here. So this BA is here, this BA is here, right? And then this BA and C, and then this C is here, then this BA, and then there will be C also. So C and C. Is this fine to everyone? That there will be 4 productions. I mean, this BA will come with BA because this is A. So BA, BA, CC. Okay, this is capital C anyway. So BA, BA, CC, BAC, and CBA. Okay, there will be the four you can say combinations. Understood? So now we need to solve further. This is capital C, by the way. Tell me, is there a left recursion here? Is there a left recursion here? Since there's a left recursion here, let's just quickly remove this. Okay, let's just quickly remove the left recursion. Can you tell me how to remove the left recursion? Let's just quickly solve this. So since there's a left recursion, we can remove this. How? See here, wherever is no left recursion, you write it first, which means you will be writing it capital C, VA, and then capital C, right? And then you will say, let's suppose this is B star or B prime. Okay. Now, wherever is the left recursion? Where is the left recursion? At this place and this place. So you will convert that to right recursion, basically. Okay. So first of all, tell me, is this okay? We convert to the right recursion, or right recursion is also a problem? This is ABA, and then B star, and then AC, and then B prime, right? Epsilon. So right recursion is okay, right? See, still there's a recursion, which is a right recursion. We have converted our left recursion to right recursion, but that's fine because right recursion is not a problem to the top-down parser. So that's why it is fine. Okay. Now tell me, is this okay? Which means, do we have any recursion here? I think this is fine, right? So now let's just finally copy this. C gives B and then B. So I think we can directly copy with this C, and then we need to replace, or we need to basically first replace, and then we need to remove the left recursion from this also. C, B prime. Then B. Now this is again having the, so these are the final answers. So this is again having the left recursion. Can you quickly tell me what is the removal? You will see it will anyway start with B and then C prime, and then C prime will go to, the C prime will go to this BA, B prime, C prime, CB prime, right? C, B prime, and then C prime, and then epsilon. Okay, so this is the answer. This is the answer. Let's just check. So yeah, they have written this directly. Now they are saying, okay, instead of B prime, they are using this BR. That's fine. So they are saying this, if you replace has the left recursion. So now it will be B gives C B A B prime, C C B prime, and then B prime is A B prime. Yeah, AC B prime, and then epsilon. Okay. And then the C will be B C prime, and then the C prime will be B A B prime C prime, and so on, right? So I think that's the correct answer. Okay, understood? Let me know. So is the steps clear to everyone? That you first need to fix the order. So what are the steps? What are the steps? Fix order of non-terminals, and then copy productions in order, and replace productions if it contains the previous non-terminal, and then remove direct left recursion. Okay. Have you seen these in the theory lectures? Have you seen this particular indirect left recursion? Yes, right? Okay. Now let's move further. Now what they're saying, this grammar is ambiguous. Now they're saying to demonstrate the ambiguity, we use a pair of derivations. Here are the 5 different pairs. For each of the pair of derivations, circle OK if the pair correctly proves that the grammar is ambiguous. Okay, so this grammar is given to you. Okay, this grammar is given to you. Now tell me, is this the correct proof to say the grammar is ambiguous? They are saying this is ambiguous. Is this the correct proof? They're having, I think, this is the one production. So I think they're doing the leftmost, right? This is the leftmost derivation. This is the leftmost derivation. This is right. This is right. This is rightmost derivation, right? So they have shown two different derivation of BBB. One is leftmost, one is rightmost. Is this a correct proof? Is this the correct proof? No, right? This is not the correct proof. Because you need to show either two leftmost derivation, two rightmost derivation, or two parse tree. It's not like that one leftmost derivation, one rightmost derivation. Anyway, this one leftmost, one rightmost always exists, right? It always exists. Obviously, it will exist. I mean, see, this is the left, this is right. Anyway, there will be different, right? This will anyway exist. Okay, so that's why this is wrong, basically proof, right? Wrong proof. The grammar is ambiguous, but the proof is wrong. What about this? Here they have done, I think, here they have done leftmost. Okay, this is also they have done left. Okay, yeah, is this the correct proof? Tell me, is this the correct proof? See, this B they have reduced to this B, and then C they have reduced to epsilon. But here they have reduced this B to epsilon and C to B. Is this the correct proof? I think this is the correct proof, right? Because this is also the leftmost derivation. This is also the leftmost derivation. So that's the okay. Okay. What about this? What about this? Is this the correct proof? This is leftmost derivation. This is no, this is the right one, right? So that's wrong. Okay. And then you can do this D and D. Can you do this D and D as an homework? I'm giving you intentionally so that you use your own brain, right? Okay. So answer is on the next page, but do this as an homework. Now what they're saying, this grammar is ambiguous. Show the two parse tree for this. Okay. Can you draw two parse trees? Maybe you can try this, right? That's also easy question. You just try two parse trees for this particular string. Answer is on the next page. Okay. That's also the easy question. Now what they're saying, consider the following ambiguous grammar. Okay. Give an example of a string for which the grammar has two different parse trees. Again, two different parse trees for some string they're asking. Okay. So do you want to try this? Maybe see this A is in the between. Maybe you can have BAB, right? So you can have BAB. Okay. So for BAB, there could be two different parse trees. First, you can take this, and then in the next parse tree, you can take this, right? Easy question. Easy question. So answer is here. Yeah, they have also used BAB, but yeah, that's easy question. You just try to draw the parse trees. Okay. Let's see this. What is the relationship between the set S of ambiguous grammars and the set of LL1 grammars? Okay. So what is the relationship between the ambiguous grammars and the set of LL1 grammars? Let's suppose this is S, which is set of all ambiguous grammars. And there are LL1 grammars. Can you say that there is some intersection? No, right? So S is a proper subset. Is this true that S is a proper subset? Which means is LL1 this? Obviously no. Actually, there is no relation. So this intersection is empty, right? So neither S is a proper subset. Okay. So here, neither S is a proper subset, not LL1 is a proper subset. Their intersection is non-empty? No. Their intersection is empty? Yes. They are same? Obviously no. Okay. Okay. So these are few questions which I want you to do because then you understand the concept really well. Now let's just solve this last question. What they're saying, this multi-part question concerns the expression grammars. Consider the grammar. Okay. So some grammar is given to us. There is a stratified grammar. So they have modified this grammar. I think they have removed the left recursion and these things, right? So this grammar is given. Now what they're saying, that is this grammar ambiguous, unambiguous, impossible to tell provided data. Okay. So what do you think? Is this ambiguous or unambiguous? Okay, we will come to that. First, tell me, here using this grammar, can you tell me, is multiplication precedence over the multiplication is having higher precedence over the division, or division is having higher precedence, or they have the same precedence? The question of precedence between is meaningless. No. So tell me which one is having higher precedence. So if this particular grammar is given, can you tell me which one is having the higher precedence? multiplication or plus? They're asking multiplication and division. See, which is far from the start symbol. Here, this is E. It will go to T and T plus E. Then this is multiplication. This is division. Are they having same precedence? Or multiplication is having higher or something like this? Tell me. See, in this particular grammar, you will say that multiplication and division are having the same precedence because they are on the same level, right? They are on the same level. So basically this E can produce this T, and then this T may go to P into E, I mean, depending on the string, or maybe P slash T. So if something, let's suppose if I just ask you between plus and multiplication, which one is having the higher precedence between the plus and multiplication in this? Tell me. Plus and multiplication, which one is having higher? Multiplication, right? Why? Because it is far from start symbol. If it is far from start symbol, then it will get evaluated first, right? So this is E, then you will say it is maybe you can have T plus E, but here this will be P into E. And first you will be driving using the multiplication, right? And then you will later on see this plus. Okay, so you will later on see this plus. If it is far from the start symbol, then it is having the higher precedence. So that is why this multiplication is having higher precedence. If I just ask you between division and plus, then which one is having higher precedence? Division. If I just ask you plus and minus, then equal. If I ask you, let's suppose multiplication and division, then if they're on the same level, then this is equal. Okay, so answer is C. C means multiplication and division have the same precedence. Okay, what about this addition and subtraction? Okay, can you tell me left associative addition about the addition and subtraction? Is this left associative, right associative? Can you tell me something about it? This is plus E, this is minus E. This is right recursion, right? So they are left or right associative. If this is right recursion, then this is right associative, right? Right associative. So basically, if it is right recursion, then this will be right associative. So both are right associative. So you will say it is right associative only. Is G LL1 or not? That's what we need to basically check. Okay, whether it is LL1 or not, we can check it. Okay, we can check it. Now, since there is no particular algorithm to tell whether it is ambiguous or not, so that's why they will not ask in the exam also. Okay, most probably they will not ask in the exam. But can you tell me if this is ambiguous using some intuition? If this is ambiguous or not? See, there is no algorithm, but you can say that this is unambiguous. Why? Because it seems like that whatever you want to generate, okay, whatever you want to generate, basically you have just one fixed way, which means if let's suppose you want to generate plus or minus or something, then if you want to generate plus, yeah, it is somewhat similar to ETF grammar. Yes. So if you want to generate plus, then it is basically you will be going to this, not to this, right? Or I mean, there is no fixed way, but this grammar, okay, obviously there is no algorithm, so that's why I cannot prove it, and there is no way to prove it whether it is ambiguous or unambiguous. But this grammar is unambiguous grammar. Okay, yeah, this grammar is unambiguous grammar. So basically there is there is no particular algorithm to check, but since the precedence and associativity is well defined, and obviously like if you want to generate something, there is a fixed way, which means if this is E, and if you want to generate, let's suppose you want to generate ID plus ID into ID. Okay, suppose you want to generate something like this. If you want to generate this, then you will say that should you be going to this plus or minus? Then you will be definitely going to plus first, right? I mean, you will not go to the minus, so you will go into the plus. So that's why this is t plus e. And then from this t, this is for sure that you will go to p and then id, because this is id only. There is no other parse tree. From this e, if you want to generate id into id, then first just label it down, and then use this into, right? So it seems like there is only one way. Let's suppose if it is minus, are there multiple ways? id plus id minus id. Then what you will do? Can you use this or this, any one of this? Let's just check. See, if you let's suppose use this, then can you ever generate this? See, if you do t minus e, then it means using this t, you need to generate id plus id, right? But t is just a term. It's I mean, using this t, you cannot go back. You cannot generate this plus. Basically, t is only for into and multiplication. So if you choose what I'm saying here, if you choose from this e, if you choose t minus e, if you choose this t minus e, then using this t only, you need to generate id plus id, right? But is there a way? Using this t, can you go back? No, right? So basically, using this t, you can't generate this plus, basically. I mean, if you go to this e, it will come with the bracket. So basically here, the things are well defined in the sense that the priority is that, okay, plus is left associative, it is right associative. And if there are same precedence, then we will go with the associativeness. So basically, if it is having the well-defined things that, okay, this is associativity is defined, precedence is defined, then these kind of grammars are generally unambiguous, but still there is no algorithm. So I'm not saying that there's an algorithm. I'm just saying that if precedence and the associativity is well-defined, then generally these grammars are unambiguous. And obviously they won't ask in the exam. Okay, they won't ask. If there's ambiguous, then most probably they may ask. Because for the ambiguous, it is as a human, maybe you can see if there are multiple parse tree. If this is unambiguous, they might not ask, okay, for the unambiguous grammar. And also this is LL1. Okay, this is LL1. You can check. Okay, this is LL1 grammar. If it is LL1, then obviously it is unambiguous, right? Okay, so this is LL1 grammar. Okay, so these okay, sorry, this is not LL1. So we can check, but yeah, this is coming out to be not LL1. That is fine. Yeah, obviously this is not LL1 because can anyone tell me quickly the reason why it is not LL1? Why it is not LL1? Can anyone tell me? Can anyone tell me the reason quickly? Yeah, this is the left factor, right? Because of the left factor. Okay, that's why it is not LL1. I mean, you can quickly check it. Okay, but if generally I'm saying if the things are well defined, which means associative precedence, if these things are defined, then this is basically unambiguous grammar generally. But there is no algorithm as such. Okay, they have asked it maybe because they in the lecture itself they may have used this grammar. Okay, and in the lecture itself they may have said that this is a well defined unambiguous grammar, maybe. Okay, that's why probably they have asked it. Okay, so these are the questions that we want to solve in this particular lecture. So these are easy questions, and from this LL1, there are only easy questions that they have asked in the gate. Okay, so also there cannot be too tough question because they just ask for first and follow and whether it is LL1 or not. But when we go to the bottom of Parser, then the things will become more and more interesting. Okay, so thank you everyone. Take care. Bye bye.